Right, number 1 so is 4x over 3 plus 1 is less than or equal to 3x minus 5 over 2. Right. When you have common denominator or fractions, what you need to get, I answered my own question, but you need to get a common denominator. Right. What's the common denominator here? 6, isn't it? Right. Okay, 6 is positive, so I can definitely use it. Okay, so the thing with inequalities is you have to make sure your common denominator is positive. And 6 is clearly positive, isn't it? So, yeah, I don't need to worry about the common denominator, right? When we get on to number 2, you'll see that you need to make sure that your common denominator is positive. Because if your common denominator is a negative number, you need to reverse this. So you have to be sure it's positive. So 3 into 6 goes twice, 2 multiplied by whatever is above the line. Plus 1 into 6 goes 6 times 6 multiplied by whatever is above the line. Less than or equal to 3x is over 1. 1 into 6 goes 6 times 6 multiplied by whatever is above the line. 2 into 6 goes 3 times 3 multiplied by whatever is above the line. Okay, I've evened everything up so the common denominator has done its job because I know two sides. So once you know two sides, you can drop the common denominator. Multiplying out, I get 8x plus 6 is less than or equal to 18x minus 15. X is on one side, numbers on the other. So 8x minus 18x is less than or equal to minus 15 minus 6. Okay, so that would be minus 10x is less than or equal to minus 21. So then divide everything by minus 10. Remember, when you divide by a negative number, you need to reverse the inequality. So it was less than or equal to, it's now greater than or equal to. Okay, they cancel, you get x is greater than or equal to plus 2.1. Is that okay? That'll do me. It doesn't say draw a number line, but if I was drawing a number line, I'd be starting at 2.1. 2.1 will be included, it's real numbers, big thick heavy line and an arrow. So 2.1, 3, 4, and is that right? Okay, but you don't need to do a number line, that's fine, that's the answer. Is that okay? Are we good? Yeah. Right, number 2, am I doing number 2? Yeah. Yeah. Going, am I okay? Yeah. Right, number 2. Right, here's what I'm talking about. X plus 3x all over x. That must be a mistake, girls, because x plus 3x. I'd say it should be just x plus 3. Okay, because x plus 3x is 4x. Right, okay, so it wouldn't be written like that. I'd say that's a typo. X minus 4 is greater than minus 2. It actually doesn't matter whether you did it with the typo or not, okay? Right, now, this time, fraction, common denominator, what's the common denominator? X minus 4, but x minus 4 could be negative, couldn't it? Depends on what x is. Like if x is 1, that's minus 3. If x is 7, that's plus 3. So it could be positive, could be negative, we're not sure. So you have to make sure that your common denominator is positive. So instead of making it x minus 4, let's go with what? X minus 4 to be squared. Okay, now you can multiply each term by the x minus 4 to be squared, or you can just do a common denominator. Do you want to do a common denominator, or do you just want to multiply each term? Which do you prefer? Common denominator, right, okay, good, consistent. X minus 4, instead of x minus 4 to be squared, I'm just going to write it as x minus 4, x minus 4. Is that right? Okay, so that goes in. X minus 4 into that goes how many times? It goes x minus 4 times, doesn't it? Because one of the x minus 4s is there, so it goes in x minus 4 times. So it's x minus 4 multiplied by x minus 3. Are you with me? Right, greater than, 1 goes into that. What does 1 go into that? X minus 4 times x minus 4 times. Agreed? Right, common denominator has done its job. Drop it. It's evened up both sides. Now you're just multiplying it out and tidying it up. So that's multiplying out here, x squared minus 4x plus 3x minus 12. Yeah, over this side, I'll leave the minus 2 a minute, and I'll just, that's squared. So square the first, twice the first by the second, square the last. Is that okay? With me? Right, that's x squared. I might as well tidy up those bits while I'm here. Minus x minus 12 is greater than, multiplying out, minus 2x squared plus 16x minus 32. Just multiplied in there by minus 2. Is that right? X is, bring everything to the left. Okay, so x squared plus 2x squared when it comes over becomes 3x squared. I have minus x minus 16 when it comes over becomes minus 17x. Agreed? Minus 12 plus 32 when it comes over, excuse me, becomes plus 20 is greater than 0. Would you agree? Right, this is a quadratic inequality. You have to draw a graph. Okay, that's how you solve quadratic inequalities. You have to draw a graph. Remember those? Okay, so in order to draw the graph, you need to, you know it's going to be U-shaped. You need to know where it cuts the x-axis. So to find out where it cuts the x-axis, you factorize and let it equal. So you let it equal to 0 and you factorize, is what I meant to say. So you let it equal to 0 and you factorize. So we have two sets of brackets, 3x and x, 20, no. Is that a minus? No. No. Sorry, what did you get?
I did it with the 3x squared, and then I ended up, my quadratic equation was 3x squared minus 16x minus 16.
Have I done something wrong? So where did I go wrong?
Well, initially, well, I don't know if it was the 3x at the start. Do you remember you said it was probably the
Oh,
3x?
it's the 3x, yeah. Yeah, it's probably a mistake. Yeah.
Like with that quadratic equation, I got the answer.
3 fours, 12. Do you know, it's actually, yeah, it's actually this, it's fine, as in I haven't made a mistake, but yeah, you got what you got. Look, we're learning the technique as opposed to the answer, because I know it's a typo, right? A minus and a minus, that'll give me minus 5x minus 12x, which is minus 17x, so I'm right. Okay, so that gives me x is equal to 5 over 3 and x is equal to 4 over 3, yeah? Okay. Sorry? Say that again? X equals 4 it is. God, yeah. Right, that's a test and you passed. Well done. Right, okay. Right, are we okay? So then it's crossing at 4 and it's crossing at 5 and 5 over 3. So 5 over 3, 1 and 2/3. And it's crossing at 4. It's U-shaped. Okay, and the question is, where is it greater than 0? So where is it greater than the x-axis? So this bit here is greater than the x-axis, and this bit here is greater than the x-axis. So when x is less than 5 over 3, and when x is greater than 4, that whole graph is greater than the x-axis. Yeah? Okay, that's your answer. Okay? Questions? Okay, I know you did it probably with x plus 3x, but that's definitely a typo because x plus 3x would be 4x, so I would have written down 4x. Yeah.
Could you write that as a compound inequality?
No, you can, but it's weird, like, because our compound inequality is really like that between, and it's not really between anything. Do you know, this, yeah, you know, you could write it as x is greater than 5 over, no, it's x is less than 5 over 3 and greater than 4, which isn't really correct, because normally with this symbol they use, you know, that's between, so it's kind of backwards. So yeah, if it's all one section, it's a compound inequality, and if it's in 2 bits, I give my answer in 2 bits. That's how I know what I'm doing, right? Okay, as in if the answer is in one bit, then it's compound inequality, and if it's in 2 bits, it's 2 separate bits. Is that right? Okay, any more questions for me there? Sorry, don't mind that there at the end. Right, are we good? I know you probably got different answers because I wrote it down wrong. Shame on me. Right, okay, number 3. Am I doing it? Right, okay, let's do it by sketching a graph. So it's x plus 3 equals 2. So sketch a graph, you ignore the 2 a minute, right? Just call y equals x plus 3. Okay, so you know this was originally a line, right? Okay, but the modulus turns it into a V-shaped. Would you agree? Agreed? And the bottom of the V hits the x-axis. Isn't that right? So you really need to find out where that line, so if you started at the line, where it cuts the x-axis, doesn't it? Would you agree? So you want to find out where does the line y equals x plus 3, where does that cut the x-axis? So what's the rule? Cuts the x-axis what? What's the rule from coordinate geometry? Cuts x-axis. You let y equals 0. Would you agree? Cuts x-axis, y equals 0. Cuts y-axis, x is 0. Right? So everywhere I see a y, put in a 0. So y equals x plus 3. Rearrange, and x is equal to minus 3. So that line cuts the x-axis at 0 minus 3. Sorry. You should have been shouting at me there. Minus 3, 0, even. Right? Is that okay? Now, so when I'm drawing the graph, I know the bottom of the V is going to be there, minus 3. Agreed? Now, I don't know what way my line's going to go. Sure I don't. How steep it's going to be. Sure I don't. So what would I suggest? So I have 1 point. What would I would get a point here. Agreed? And would I get a point at this side? So I'm going to get a point at either side, because I know it's 2 straight lines that make a V, doesn't I? So I would get a point either side. So I'm going to let x equal to minus 4. Now, it's my choice. I could let x equal to minus 5, or I could let x equal to minus 10, or whatever I want. Okay? I just need to get a point at this side, right? So I'm just choosing let x equal minus 4. So y is equal to the modulus of minus 4 plus 3. So that means y is equal to minus 4 plus 3 is minus 1. The modulus of that is 1. Would you agree? So that's the point, minus 4, 1. You with me? Minus 4, 1. Okay, and then I'm going to let x equal minus 2. Okay, so that means y is equal to the modulus of minus 2 plus 3. So that means y is equal to the modulus of plus 1, which is just 1. So that's minus 2, 1. Agreed? So there we are. So that's the line going that way, and that's the line going that way. Agreed? Are you all with me? So that's how you draw those, right? You find out, if it was just a straight line, you find out where it cuts the x-axis. That's where the point of the V is going to be, right? And then you get 1 point either side of that point. So you get minus, here it turned out to be minus 3, so you get 1 below minus 3, 1 above minus 3. If it turned out to be 2, you'd get a point below 2 and a point above 2. So you know, so you have a slope for each one. Is that okay? Yes.
What's that 2 there one?
That one?
Did you change into y?
Oh, yeah, I haven't got that yet. I haven't finished answering it yet. Yes, I haven't finished the question yet. So the question was, where does x plus 3 equals 2? Agreed? But I've just drawn that. So that is f of x or y. That's the graph. Where does the y equal 2? Agreed? That's y. Yeah? So I go to the y-axis, I go to 2 on the y-axis, and I draw a line across. And I draw where it hits the graph twice, and I draw a line down at both points it hits the graph. And it's probably going to be, I didn't draw it very accurately, but you would draw it accurately, and I'd say x is 0, and probably x is minus 5. Okay, is that right? So when I drew it down here, it hit 0, and when I drew it down over here, it hit minus 5. Obviously, you'd have a lovely accurate graph on boxy paper, right? Is that okay? So that's how you solve it graphically. How you solve it algebraically, which is part 2, is x plus 3, the modulus of x plus 3 equals 2. So remember, the modulus means you can take the positive or the negative, agreed? Right, so we're not sure, so what will we do? Square both sides. So you square this side and square this side. Remember, you can do anything you want to an equation as long as you do it to both sides. So squaring this side, then you don't have to worry about the plus and the minus, because if it's squared, it's positive anyway. So you don't have to worry about whether it's a plus or a minus or whatever. So x squared, twice the first by the second, 6x, square the last, over this side, square 2, and you get 4. Yeah? Bring over the 4, you get x squared plus 6x plus 5 equals 0. So factorize x and x, 5 and 1, a plus and a plus. So the answer is x is equal to minus 5 and x is equal to minus 1. So that just shows how off my graph was. I got the minus 5, but I got 0, and minus 1 is the answer. So my graph was well off. Okay? But you'd be drawing your graphs on lovely boxy paper, and it might be bang on, because graphs aren't accurate, right? But it wouldn't be too far off. Okay? I was really far off because I scribbled my graph in the corner of a whiteboard. Okay? Right, are we good? Questions? No. Right, okay, that was number 2. It was number 3 even. Number 4, am I doing it? It's a modulus again, square both sides. Do you need me to do it? I just did one, but I'm happy to do a second one if you want me to. Anyone? Want it? No? All good? Right, number 5 was next. Am I doing number 5? Yeah, with the logs. Yeah, I really want to do logs. I love logs. X equals log of 2 to the base 10. So everywhere I see that figure, I'm going to replace it with an x. And everywhere I see log of 3 to the base 10, I'm replacing, sorry, that should be a 10. I'm replacing that with a y. Okay? So log, and then it says express in terms of x and y. So log to the base 10 of the square root of 32 over 27. First observation, they're log to the base 10. Right, this is log to the base 10, so I don't need to change my base. Is that alright? First observation. Right? Second observation, or second thing I need to do, that square root sign. Square root signs are, in indices and logs, they don't mean anything. So how do I need to write that as? It's 32 over 27 to the power of, someone answer me, right? A half, thank you. Right, to the power of a half. You have to remember that square root is to the power of a half. Right? Rules of logs, I can bring that half down, can't I? So that would be a half log of 10, 32 over 27. With me? Rules of logs. When I have a fraction, what can I do? I can split it up and put a minus between it. So there's a half in front of the whole lot. So I'll just put the half outside the bracket for the moment. So half of log of 32 minus log of 27 to the base 10. With me? Now, referring back to the top, this is 2. This is 3, so I can write 32 as a power of 2, can't I? And I can write 27 as a power of 3, can't I? Okay, so half of log 10, okay, 2 to the power of 5, is it? 2 by 2 by 2 by 2. I ran out of 2s, yeah, 5. Okay, so 2 to the power of 5, and this one is 3 to the power of 3, isn't it? You all with me? Okay, I have powers. What can I do with the powers? Bring them down in front. Okay, so again, I'm just leaving the half there at the very front. I'll deal with that in a minute. So I can bring the 5 down there. So that would be 5 log of 2 to the base 10 minus log 3, there's a 3 there, log of 3 to the base 10. Agreed? You all with me? So that's a half into, that's 5x, isn't it? Because they told me all that was x. So that's 5x, isn't it? Minus 3y. Okay, and then divide everything by 2. So it's 5 over 2x minus 3 over 2y. Is that okay? Part 2? I doing it? Yeah. Right. I'm rubbing out a board while you're doing that. Have I time? Oh, I have loads. Right. It's like there's people moving upstairs, isn't there? It's like it's the end of the class. They're always banging upstairs. 4,000 over 9. Right? Okay. So, sorry, it's still frozen. Thank you. Right, so 4,000 over 9. Right, bearing in mind, right, I need to write it in terms of 2s and 3s. Okay? Right, first thing is it's a fraction. So what do I do there? Minus it. So it's log of 4,000 minus log of 9, right, to the base 10. Yeah? Okay? Right. Now I can't write that as the power of 2. Sure I can't? Right, okay. But it's like, I'd be looking for factors that are either factors of 10, right, okay, powers of 10 or powers of 2, powers of 2. So can anyone split that into factor where it's either a factor of 10 because there's a base 10 or 2s because of this up here at the top? So can anyone split it up 4,000 into factors? It can be, it's the easiest factors, 4 by 1,000. Now, how do I know this? Right, because I've been doing it for years, right, and 4 is, it can be written as a power of 2, can't it? And 1,000 can be written as a power of 10. Would you agree? Right, okay, minus log, and I'm going to write 9 as 3 squared because of this up here at the top of the sum. Right, okay, I'm going to break this up. This is a product, so that means I can write it as a plus. And I'm going to bring that 2 down in front there. 2 log of 3 to the base 10. You all with me? Okay, how do I write that 4? How do I write that 4? 2 squared. So that's log of 10 of 2 squared. Now I can turn this back into a number. Because 10 to the power of what gives me 1,000? 10 to the power of 3 gives me 1,000. So that's just the number 3. Right, okay, and here that's 2y, isn't it? Is that alright? Okay, working here, I can bring the power down in front. That's 2 log of 2 to the base 10 plus 3 minus 2y, and then that's x. So that's 2x plus 3 minus 2y. With me? Done. It's in terms of x and y, isn't it? Right? Are we good? Right. Number 7, I presume yes. Number 7 is 1 over log of x to the base a plus 1 all over log to the base b of x plus 1 over log of x to the base c and you're trying to turn that into log to the base x of ABC. Right? So I'm going to manipulate the left hand side and turn it into that. So I'm not going to look at that answer only to say this is in the base A, this is the base B, this is the base C, so all the bases are different, and the answer is the base X, isn't it? So I need to change all the bases. Yeah? Yeah. So I need to change all of these to a base X. Would you agree? Okay. So look, if I just had log of A, log of X to the base A, right? If I just not 1 over it, just it, you would just, to change that base, you would just change it to its new base, right? And it's the log of the old base to the new base. That's the rule, right? Okay? So if I just had log of X to the base A, that's what it would be, the base changed. Agreed? When it's 1 over, that's the reciprocal of our fraction. So what do I need to do with this? Flip it, right? So 1 over is a reciprocal, it's called. Very fancy name for saying turn it upside down, right? So when I change that, that would be log of A to the base X over log of X to the base X. Yeah? Okay, this one, again, if I was to change it, that's what it looked like, except that would be a B. But now it's log of 1 over, it's flip it upside down. So log of X plus log of C to the base X over log of X to the base X. So that's changing the base rule. I don't know, it was the last rule we did anyway when we did the rules of logs. It was 7 or 6 or 7 or whatever it was. Is that okay? But we know log of X to the base X is what? 1. So that's log of A over 1. So I'm just going to drop underneath the line, because all underneath the lines are 1, aren't they? Because log of X to the base X is 1. With me? This was originally a product, wasn't it? Okay, and they split them up and plussed them. So that was originally log to the base X of A multiplied by B multiplied by C, which is what they told me the answer would be. Okay, is that right? We good? I'll just freeze that and clean the board. Right, okay, number 8, am I doing 8? Yeah, so number 8 is log to the base, it's frozen, yeah, you can't see the pen anyway, so log of to the base 6 of x minus 3 plus log of 6 of x plus 2 equals a number. So basically what you want to do with this is turn this into one log on the left hand side, and then you turn it back into an index because it's log equal to a number, right? Okay, so this was originally a product, would you agree? Because they're plussed. So it was originally x minus 3 times x minus 2, right, equal to 1. So when you've log of something equals a number, you turn it back to a power. So it's 6 to the power of 1 equals x minus 3 times x minus 2. And then that's just a quadratic equation, so you multiply out, square the first, or x by x, then you have minus 3x minus 2x is minus 5x plus 6 when you put it together. Okay? I just bring over that 6 and you get x squared minus 5x equals 0. So that's x times x minus 5 equals 0. And when you solve, you get x is 0 and x is 5. Agreed? When you factorize that, take out what's common, let the x equal 0, let the x minus 5 equal 0, you get x equals 5. Just make sure you check, right? If x is 0, I'll be getting the log of minus 3 here. You can't get the log of a negative number. So x is not, that is not an answer. When the x is 5, I'll be getting the log of 2 and the log of 7. So it's fine. Get the logs of positive numbers. So yes, this is an answer. That's question 8. Yeah. Oh. Sorry, sorry, that was a +2. I wrote it down as a -2. So I think that would be minus x. So that would be minus x, and that would be x minus 1. And then you get x is equal to 1. No. Sorry? Oh, it's a -6. Yeah. Okay. Oh yeah, so I don't end up with that at all. I end up with a -12, so you end up with 3 and 4 or something. Yeah, sorry girls, I wrote a wrong sign. That should be a +2. Right, so then when you rearrange, you'll get x squared minus x minus 12 equals 0. 2 sets of brackets, x and x, 4 and 3, a minus and a plus. Let each bracket equal 0, you get x equals 4 and x equals -3. And just checking here, you'll be getting log of -6, which is not an answer. You can't get the log of a negative number. So you just get x is 4. That's the only answer. Yes. Yeah. Okay, sorry about that, girls. Okay, I left out, wrote a minus instead of a plus. Yes.
You know, if you were to get that sum in a test, like, would you have to cross out the -3 and...
Can I tell you, in Leaving Certs gone by, they penalise for it and they've not penalised for it. Okay, as in if they're trying to give you marks, they haven't penalised, and if they're trying to take them off you, they've penalised. Right, as in if they're trying to make it, you know, they make it fit the curve. Right, okay, so my advice is do it just in case it's a year they're going to penalise for it. So do it. If I give it to you in a test, I will penalise for it, okay? Because it's better to do it. Right, okay, I'm up to number 8, so girls, will you look at 9, 10, 11 and 12 for tonight? Again, have another look at them, and also start revising yourself in the chapter. And if there's anything comes up in the chapter, right, we'll go through that as well tomorrow and Wednesday, okay? So the test is off till Thursday. But you bring the questions, not me.